How will the universe end? It's a question that has been asked since the beginning of civilization. The ancient Greeks believed that the world would end when a giant named Gaia emerged from the Earth's crust, scraping all the heavenly bodies and destroying the Earth. Ancient Greek philosopher Aristotle believed that the world would end in 1948 when the sky cracked, falling onto the rest of the planets and Earth. However, after extensive research, I believe that the universe will end in heat death, a phase in which the universe has reached maximum entropy and exists as a giant cloud of random matter. Before we discuss heat death, we need to discuss the size of the universe and entropy. This is an image of the universe. From the center, one can see 800 light years either way. Scientists aren't sure if the black area is the end of the universe or simply as far as they can see. However, presently, the universe is defined as being a closed system. Scientists believe that what they can see is the entire universe. In this image, there are two vessels, a cold vessel and a warm vessel. This system is organized due to this separation. However, if I were to open the valve in between the two vessels, they would mix, and their randomness would increase, their entropy would increase. The universe is similar to these two vessels in the fact that it is a closed system. And since it is a closed system, no external energy sources can add more order to the system. Therefore, entropy will continue to increase in the universe, regardless of any external force, because there is no force external to the universe. British physicist William Thomson, more commonly known as Lord Kelvin, was the first person to come up with the idea of heat death in the year 1851. He observed that temperature difference is required for there to be thermodynamic free energy. Thermodynamic energy is needed to conduct work. He hypothesized that since the universe is a closed system, its entropy will increase, and its thermodynamic energy will decrease, thus ending all process in the universe, including life. Over a time span of trillions of years, stars will begin to cool and die, and the universe will become more uniform in temperature. During heat death, planets like the Earth will cool. The most random or entropic phenomenon in the universe are black holes. Near the start of heat death, the universe will collapse into a single supermassive black hole. Once everything has been consumed, heat death has been achieved. This is what the universe will look like at heat death, a super dim mixture of gases. During heat death, time reference will be lost. 1 second will still be a second, but time will not travel forwards or backwards uniformly. This is because we rely on entropic processes to determine the direction of time. For example, if we see an ice cube melt in a glass, we know that time has traveled forward. If we see ice form in a glass spontaneously, we know that time has traveled backwards, despite the fact that this never happens. If we see a child fall off of a bike and start crying, we know that time has traveled forward. The opposite happens, we know time has gone in reverse. However, there will be no processes in a heat death universe, therefore no time reference. Some scientists believe that entropy is independent of gravity. Therefore, they believe that rather than a heat death occurring, the universe will simply collapse back in on itself and start a new universe. Peter Griffin is not using any energy to make those objects float. Another complication to the theory is that the universe may be infinite, therefore energy can always be externally obtained.